Hello and welcome to this Sails 1.0 tutorial video. Today we're going to be creating a simple chat app using the built-in real-time features of Sails, also known as Resourceful PubSub. This is a really useful feature that lets you get up and running with WebSockets and real-time notifications without writing a lot of code. We'll actually be writing almost no back-end code for this app. Instead, we'll be relying mainly on the API that Sails provides for us, also known as blueprints. The app we're going to make today is a really simple Gitter-style chat room. We use Gitter at the Sails company to interact with the community, and it's a really cool app with lots of features. Our version will be super stripped down so that we can concentrate on just the basics of real-time with Sails. Specifically, our app will have username-only login. We're not going to be authenticating with passwords. We'll have one chat room for everybody who logs in. Our list of users will display who's logged in and who's logged out, but it won't have real-time presence indicators showing who's actively using the app. And we'll just use jQuery for the front end. Sails is a fairly opinionated framework when it comes to the back end, but for the front end, you can do whatever you want. So rather than making this a React-specific or Angular-specific tutorial, we're going to do it framework-free on the front end. In the future, we might expand this tutorial to do things like authentication, multiple rooms, private rooms, real-time presence indicators, and asset handling via Webpack instead of Grunt. All right, let's get started. The best way to follow this tutorial is to check out the repo on GitHub at github.com/saleshhq/saleschat-1.0. I'm mostly going to be highlighting and explaining code from the repo rather than subjecting you to my typing in real time. Now, it's far outside the scope of this video to get into all of the best practices around planning, architecting, and building a web app with Sails. For that, a good resource is the Sails in Action book that just came out by Earl Nathan and Mike McNeil. Definitely check that out. But even for a super simple app like this, there's things you can do to kind of keep yourself focused. So here's the rough steps I took when building Sails Chat 1.0. First, I made some wireframes to just get the look of the UI that we want. Then we mock up some HTML pages from those wireframes. Next, we add some JavaScript to use stubbed data, that's just fake data, to recreate those mockups. Then we add our models and hook up the blueprint endpoints. Then finally, we add socket listeners and handlers to update all the stuff in real time. And after that, we just iterate. We add features and fix issues. So step number one, wireframes. Here's some balsamic mockups I made for Sails Chat. You can see the login page is, as promised, just a welcome page and an invitation to enter a username. The chat page just has a big header identifying the logged in user, the single chat room, and a list of users. You can see how the chat room can include both messages from users and administrative messages about users entering and leaving. And you can see in the user list how you can tell the difference between users who are logged in and those who aren't. They are shown in italics. After taking a few minutes to build up those wireframes, the next step is to transform those into HTML mockups. You can find these in the repo if you're following along in the assets/mockups folder. This is a really important step because it lets you build and style all the pieces of your interface and get a feel for what you're going to be building dynamically. For instance, if you look at the HTML for the chat room, we can see that when we make this dynamic later, we're going to be emptying out this chat transcript element and creating new chat line and admin chat line elements, each containing text spans, and for the non-admin lines, username spans. The next step is to take these HTML mockups and make them dynamic using stubbed, again, that's just fake hard-coded data. It can be really tempting at this point, especially with Sails, to just dive in and start building your models so you can use live data in your pages. The reason I suggest taking this extra step in between is that we really want the front end to be driving the back end and not the other way around. The idea is to build up your interface and let that tell you what models and actions you need on the back end. If you're following along in the repo, if you check out the dynamic mockups tag, you can see what the code looks like at this point. Looking in the assets/js folder, you'll see we've added a few files, chatpage.js, chatroom.js, and userlist.js. As I said before, we're doing this purely using jQuery. In our case, I've chosen to make one script, chatpage.js, as kind of a controller for the two main components on the chat page, which are the chat room and the user list. So let's take a look at the chatpage.js script. The first thing we see is the comment at the top of the file letting us know what the file is for. In this case, that it's the main script for the chat page, and that its job is to load initial data and set up the other components. Since we're using jQuery, we're taking advantage of the jQuery ready shortcut function, so everything inside this function will be run after the HTML is loaded. The first thing we'll do then is declare a variable that's going to hold some data related to our app state, namely the ID of the logged in user, the current user list, and the current list of chat messages. We'll cover this sails locals reference a bit later when we take a look at our EJS files. Next, we call a couple of utility functions to get our users and messages. We'll be defining those a little bit later. Notice that these are asynchronous function calls. We're calling them with a single argument that is a callback function using the traditional node.js style, where the first parameter in the callback represents any error that occurred, and the second argument is the actual result after the asynchronous code completes. We're handling possible errors with simple alert boxes, and assuming there's no errors, we're adding the user and message data to our app variable. After we have all the data, we're creating a new chat room and user list object and giving them both a reference to the app data and then initializing them. Beneath the jQuery ready function, we've got the definitions of our two utility functions, which you can see right now are just sending back that stubbed data. We've got some to-dos to remind us to replace these with dynamic data later. But you can see that we're expecting each user object to have an ID, a username, and a flag indicating whether the user is currently online. That's what we'll use to determine how to display that user in the list on the right. And we're expecting each message object to have an ID, a populated user object, and some message text. When we actually start using the database, there will be more data in the user and message objects, including like timestamps, but we're just stubbing out what we want the backend to guarantee for us. And if it sends more, that's fine. Now, taking a look at the chatroom.js file, it tells us that this component comprises the chat transcript and the chat controls. The constructor for the chatroom object is very simple. It just keeps a reference to the app messages. And one of the two public messages on the chat room object is init, which loops through each of those messages in the room and calls the render message function to add the message to the transcript. That bind there is just to make sure that this inside render message still refers to the chat room object and it's not changed by the scope of this _.each function. That function, by the way, is coming from Lodash, which we're going to just include as one of our JavaScript dependencies. We could also, instead of using the bind, we could have just written this as a function like this. So we also define a private asynchronous send chat function that is responsible for sending new chat messages to the server, though for now, again, it just pretends to do that and returns a stubbed data object. After that, we have a DOM event handler for clicking the send chat button, which calls the send chat function and handles the response by rendering it to the transcript and refocusing on that text input. We also have a handler for pressing enter in the text input, which just simulates clicking that send button again, so we don't have to duplicate that code. Finally, we have the public render message function, which can be called to take a chat message object and build up that same HTML that we previously had in our static mockup, and then add that new line to the chat transcript. And it also has a little fancy code at the bottom to keep the transcript scrolled to the bottom when new messages are added. All right, last but not least, we have the user list component in userlist.js, which is a lot like the chat room component in its constructor and init function, but a lot simpler since it doesn't have any user interaction. It does have a public add new user to list method that is used to, surprise, add a new user to the list of users in the chat room using the same HTML that we mocked up earlier. It also has a public update user status function that can be used to switch a user in the list between the online and offline displays. One last thing before we move on to creating our models and using live data, let's take a quick look at our EJS files and the index action. I created the index action using sails generate action index --actions2, so that makes it an actions2 style action. You can learn more about actions2 and the node machine specification that they're based on in the Sails docs. This action currently has a single exit called chat page, which is a view, specifically the chat view. And since we're using the default EJS engine for our Sails app, this is going to make it point to views/chat.ejs. The action will also have two implicitly created exits called success and error that you can always call for any action. Right now, we're hard-coding in some data for the view, namely a logged in user ID and username. We'll replace that with real data soon. The layout EJS file is pretty much unchanged from the default layout EJS that you get when you create a new sales app, except that I've removed the script and script ends tags so that the default sales grunt tasks don't add every script to every page. There's nothing wrong with those default grunt tasks. Instead of removing these tags, we could have edited the pipeline.js file to kind of customize how we want those the scripts to be included. But again, that's something that's really in the scope of this video, so it's easier just to, in this case, remove them and hard code a few scripts in the head tag that will go on every page, and then add individual scripts as necessary to the templates. You can see here in the chat EJS file, it looks a lot like our chat HTML mockup with all of the dynamic data removed and with a few script tags at the top. The order is important there. And then this expose locals to browser call. What this does is take whatever locals you pass into your view, that's these over in the index action, and outputs them in a sanitized way to your view so that they're available in JavaScript as the sales locals variable. That's a great way to bootstrap data onto your page when it first loads. All right, so let's get some models going so we can use real data. As we've seen by building out our front end first, we need two models, one to hold users and one to hold chat messages. We'll create these now with sales generate model user and sales generate model chat message. These just create blank models with a little bit of scaffolding around them. But if you look at the default config models file, you'll see that by default, all of our models in Sales 1.0 will always have an ID, a created at, and updated at fields. Anyway, we'll want to add attributes to our models to make them match what we're expecting on the front end. If you're following along in the GitHub repo, you can see the updated code by checking out the added models tag. Our finished models are pretty simple. The user.js model has a required string username, a boolean indicating whether the user is on or offline, and a collection of chat message records. The chat message.js model has a link to a user record that created the message. Note that this is not required though, which lets us indicate an administrative message. That's a message about somebody joining or leaving the room by just not specifying a user. And then it has a string attribute for the message text. You'll also see that for testing, I've added some data in the config/bootstrap.js file, just so we can see something when the page first loads. I've also updated the config models.js file to set the migrate setting to alter. Otherwise, Sales will keep prompting us every time we lift to choose a migrate strategy. It gets really annoying, so just set that as early as you can. And we've also added an option in the config/datastore.js file, which sets the default disk database to the memory-only mode, so that all the data will be wiped every time you lower the app and lift it again. Now, if you go into our chat page.js front-end JavaScript file, you'll see I've replaced the stubbed-out data with io.socket.get calls. These URLs, /user and /chat message, are provided automatically by Sales because we have REST blueprints enabled. If I lift the app right now and go to /user in the browser, we'll see the list of users in the database. And if I go to the index page, you'll see it looks pretty much like it did before, except now it's using data from the database instead of hard-coded in the JavaScript file. If we peek back at the Chatroom.js file, you'll see I've replaced the code in sendChat that was stubbing out a chat message object with a call to io.socket.post, pointed at another blueprint, this one the chat message blueprint, which, when you request it with a post, will create a new chat message. So here's where things get really interesting. Because we made these requests using sockets instead of AJAX requests using jQuery, the Sales blueprints do a little bit of extra magic for us. Besides just returning the list of users and messages, the WebSocket that made the request is also subscribed to notifications about those two models and the records that were retrieved. Now, anytime a user or message is created, updated, or destroyed via blueprints, those clients will receive a notification that they can listen for and react to. So for example, if we open two tabs to the chat page, and in one we open the JavaScript console and type io.socket.on, listen for the chat message event, and a function that just logs what the notification is. And in the other one, we send a new message. We'll see that we get a real-time notification as soon as we send that new message. We can handle these notifications in our JavaScript files to update the chat transcript and the status of users in a list. The format of these notifications is laid out in the sales documentation for the Blueprint API, so definitely check that out. One thing to keep in mind about the automated notifications is that they're pretty high volume. If you subscribe to the user model, you're going to get notifications about every user that's created and every user that you fetched, with that GET request. For a simple app like what we're building, or when you're first prototyping a more complicated app, it's a huge time saver. As you get to the point where you need to restrict who gets notifications, you'll usually want to move past just using blueprints. At that point, you'll start using the other sales pub/sub methods to gain a bit more control over your subscriptions and your notifications, and we'll see some of that at the end of this video. For now, if you check out the added pub/sub handlers tag of the repo, you'll see two event handlers added to the chatpage.js file. The first handles notifications for the user model. It handles notifications for newly created users by adding them to the app's internal users array and then calling that public add new user to list method of the user list component to display the new user. It also handles updates by calling update user status to display user's new status. And if the status is offline and the user ID matches that of the current user, meaning that the notification is about whoever the logged in user is, it reloads that page. This is a simple way of ensuring that the logging out in one tab or window forces all the other open tabs for the same user to acknowledge that they've been logged out as well. In a more sophisticated chat app, you'd certainly want to be able to log out of one place and remain logged in another, like logging out on your desktop but still being logged in on your phone. What's complicated about that is what I talked about earlier about presence, about that user list kind of accurately reflecting who is actually online and who's not, which is certainly doable, but for our simple app, it's a little too complicated for this example. So for us right now, when you log out in one tab, it just logs you out everywhere. The chat page also handles the chat message notifications by updating the chat transcript. This tag of the repo also has the code for the login and logout backend actions. These are the only backend actions in the app besides index. These have to be done on the backend because they involve updating the session. I won't go over the front end of the login page in depth, but it works by calling the login action with a given username, making a put request to it. And if no such user exists, it makes a post request to the create user blueprint in order to create it. This way, the blueprint sends out that nice new user notification to all of the connected front-end clients so that they can update their lists. The logout link on the chat page works by first using the patch/user blueprint to set the user's online status to false, which causes all of the subscribed clients to update their user list display and show that username in italics. And it causes any clients that represent that user to reload their pages. And as I said before, that's just to kind of log out all of the other clients that are connected to that user. It then calls the /logout endpoint to actually clear the user from the session. So at this point, we can see if we have two tabs open and one of them is in an incognito window, we can create two users. And you can see how when the second user is created, it shows up in the list for the first user. And we can chat back and forth. And then if we log out of one of the windows, the user list of the other updates to show that the user is logged out. So this app is working pretty well, but if you've been paying close attention, you might have noticed a couple of issues with it. First of all, it's completely unsecured. And I don't mean the fact that there's no passwords, since that was by design. We knew about that. But I mean the fact that anyone could go into the JavaScript console and impersonate anyone else just by making some requests. Or you can even log somebody else out of the app. Even for a simple app like this, we can do way better than that. And it's very easy to do by just adding some policies to our app. If you check out the added policies tag of the repo, you can see the policies I added to make sure that users can only post as themselves and can only update their own records. That means they can only log themselves out. The second thing you might have noticed is that we don't have those administrative messages when a user logs in or logs out that we had in our mockups. And just like we don't want users to be able to post as other users to impersonate people, we don't want them to be able to post those admin messages themselves either. That means that we'll have to post them on the back end instead, and we'll use some of the other Sails pub sub methods to do it. Specifically, we're going to use the blast method to send out a notification to every single connected socket. If you check out the added admin messages tag of the repo, you can see how we've added blasts to the login and logout actions. Notice that we're using the same kind of data envelope as the blueprint pub sub messages, the same format, so that our existing front-end code can use those notifications without any changes. They'll look the same as the ones that come from blueprints. At this point, we can lift the app, open 2 tabs, and we see the admin messages at work. That's about it for this tutorial. I hope this has been helpful for you. There's lots of information on the Sails website about PubSub and Blueprint, and I put links to all of the relevant sections in the description of this video. Again, I hope you found this helpful, and I'm hoping to expand this example to show some other Sails features real soon.